Hi guys, this is a video showing you how you can update your metadata directory and how you can back it up, move it, and adjust your storage folder size on your SC Prime Miner. So what I've done is I've purchased a USB flash drive here, and we're going to learn how we can actually back up our metadata and, like I say, move it around and do other bits and pieces. So I'm going to stick this in my Pi now and then go upstairs, and we're going to log onto our XA miner or our pretend one, and we're going to get it all sorted out. Right, so I've got the USB disk plugged in and I've stuck it into the USB 2 port of the Raspberry Pi. This is because, as one of the people on my previous video commented, the maximum output from the USB port on the Pi 4 is 1.5 amps. So my thinking is that the USB 2 port will output at half an amp, and the hard drive attached to the USB 3 port will output at around 900 milliamps to 1 amp. So we don't want to overload our poor little Pi. If we did want to attach additional things, we can just get a powered USB port and that will solve all the problems. But again, we're keeping this as cheap as possible, so I'm just going to leave it as it is at the moment. So anyway, like I said, in this video, we're going to be doing a few different things. We're going to set up a backup for our metadata. Now it's important to keep this backed up because this keeps all the information of your contract, so we need to make sure that's backed up somewhere safe in case our micro SD card does fail at some point, which inevitably it will. The other thing a few people have mentioned on the previous video is that the micro SD card isn't the best place to store the metadata due to the read and write of it. Now I have had a look, and currently the micro SD card is not really doing much at all. There's the odd write and read to it. Now that doesn't mean that's not going to get hammered in the future when it starts getting used more. So we'll just go through changing the metadata directory, and you can then store it on a different disk if you want to, a USB drive or the actual hard disk drive that we've got attached. And to do that, we're going to need to know how we can adjust the amount of shared storage we're sharing. So that'll be our third little thing on the agenda today. So let's start with the first one, which is backing up the metadata. So basically there is a command we can run which will synchronize the metadata to our nice new USB stick. Now if we do an fdisk here, we can see that our USB stick has been detected. So we know that the device is on dev/sdb, as we can see here. So we're going to use gdisk again to go here and format the disk. So gdisk, just paste that in there. Now don't forget I am in as root, so if you're not in as root you need to do a sudo in front of this command. But to make sure you're in as root, just remember you can just type sudo su, and then when the hashtag is there you know that you're root. So we're going to do gdisk, paste that in. So just like we did before, we're going to delete the existing partition. So just double check you've got the correct device selected. So dev SDB, remember that our previous disk was dev SDA. As you can see here, it's at the top, the 5 terabyte disk, dev SDA1. So we know that this is the 128 gig USB stick. So remember the command to delete, if we press here, is going to be D to delete the partition. So we're going to press on D and hit return. We can see it says using one, so we'll do it again just to confirm there's nothing else there, and it has now been deleted. So now we're going to write that to the disk by doing a W and then hit return again. Going to ask you to confirm the procedure, press on yes and hit return. And the operation has completed. Okay, so now we're going to go back into gdisk with our same location, which was dev/sdb. And we're going to create our new partition. So just press on N, hit return, partition number 1, and then just keep pressing return through these next prompts. So now we're going to press W to write that to the disk, and again press yes again to confirm. Okay, so next up we're going to format our disk. So if you remember from last time, we need to format the partition itself, which is SDB1. So we're going to do mkfs ext4 /dev/sdb1. Just double check you're doing the correct partition and correct drive here, because if you don't, you might format the wrong disk. Okay, so after the format, similar to last time, we want to ensure that this is going to mount every time you boot up the system. So we're going to have to get the UUID of the disk. So we're going to type blkid, and we can see here dev/sdb1 UUID is this. So we're going to copy this into our clipboard by just selecting it. Right, so now we are going to do vi. We're going to edit the fs tab, which is the file that we need to edit to tell the system to mount this UUID when it boots up. So vi /etc/fs tab. Okay, so we can see here currently what is in the fs tab. So what we're going to do is pretty much copy this line, but we're going to change the mount point that we want our new drive to go into. So remember, in this we need to press I to start typing, and we get the insert appear at the bottom here. So I'm at the end of this line. I'm just going to hit return. I'll do it a couple of times to make it a bit easier to see. So we're going to do UUID equals, and then just right click your mouse, and that'll paste in the UUID that we copied before. And then we're going to mount it to /mount/ we call this one USB stick. So to get out of insert mode, remember we press escape, and then we do a colon, and then WQ for write and quit. Just press return. Okay, so now we're going to do a reboot because we want to restart the Pi and just make sure that mounts up okay. So simply just type reboot and hit return, and just wait for your Pi to start back up. Okay, our Pi has rebooted. I'm just logging back into it now, and we will sudo to su, and then we're just going to check our mount points. Hopefully, yes, USB stick is now there, so we can have a look at that. And it's obviously empty at the moment, so if we're doing df-h, we can see here we've got dev SDB1, and it's mounted to mount/USB stick. So we've got our drive set up now. So what we can do now is actually use this for our location to back up our metadata. Okay, so we're going to use a program called rsync to back up our metadata folder onto the USB stick. Now we're going to do a test first to make sure we get the right syntax, and then we can add it to the cron tab to get it to run automatically once a day. So the command we're going to type is rsync, and then we're going to do a couple of options here, which is A, which is archive, and V for verbose, so that we can actually see what's happening. Now we're going to do a dry run first, which is always advisable before you actually start synchronizing things to see what's going to happen. Now we're going to type in our source and then destination. So the source is going to be the metadata folder. So I'm going to leave it like that. There's no slash on the end because we want to copy the whole folder itself. And the location we're going to is our USB stick. So /mount/USB, and just hit tab. And we can put it in a folder if we wish, so we can have it nicely organized. So we could call it metadata backup, or whatever you want to call it. If you do want to name it something else, I'm going to leave it as metadata. So I'm actually going to remove that slash on the end, and it will pop the whole metadata folder into the root of the USB stick. So again, this is just a dry run, so nothing will actually happen when we do this. It will just tell us what will happen. And it's just showing you exactly what files are going to get copied across. Okay, so we're happy that that all looks okay. So we're going to remove the dry run bit here, and then just hit return. Now while this is happening, I'm running another window here with IOTop running, and we can just see exactly how fast things are being read and written to the USB stick. It's running at about 36 megabytes per second, which is good. So it's a few gigabytes, I believe, so it might take a while to actually go through. Now the good thing with rsync is that once it has run once, it knows what folders and files exist, so it won't keep copying them each time rsync runs. So if a folder gets changed or a file gets added, it will only copy that brand new file across to the USB stick. This will just save time in the future when you are running it on a sort of schedule. It will only copy the new files across. We are actually going to add in another switch to our rsync command, which is a bit of a scary looking one. It's --delete, but that will only delete things on the USB stick if they get removed from the source destination. So if there is a file in the metadata folder that gets removed, it will also remove it on the USB stick. Okay, so I think we're happy now that the command is finished. There's no more activity and we're back at the prompt here. So let's just have a look in here and see what we have in ls. And we can see the metadata folder there, so we can have a look at that and go inside. And we can see all of the bits and pieces have copied across with no issues. Okay, so we have our metadata folder here being backed up, which is great. But the problem is, if your metadata became corrupted somehow and you're then rsyncing across your corrupted data to your USB stick or your backup device, then you're going to end up with a synchronized corrupted folder. So what we want to do is sort of take a sort of snapshot, not an actual snapshot, but a sort of a zip of this metadata folder every X number of hours or days, depending on what you want to set, and just keep a sort of copy of this folder on our device, which we can look back to and restore if the metadata ever became corrupt itself. So doing that, you would then be able to restore your contracts, and maybe you'd lose any new contracts that you've had since the last good known zip file, but either way, at least you can restore some of it if your main metadata got corrupted. So anyway, to do that, we're going to use a program called tar. So this is basically, think of zip in Windows. We're going to just tar up the file or the folder itself and create a copy of it. So tar, and then we're going to create, and this is a verbose, and the file name being specified. This is the file name we're going to give it. Now this may look a bit complicated, but basically you can put any name you like here. I've just put metadata backup. And then this here is actually adding the time and date to the file name. This way we can be sure that whenever this runs, it will create a brand new tar file and it won't overwrite the old one. This will also allow us to easily find the sort of latest one just by the file name itself, and we're just specifying what we want to create a tar file of. So we're going to use mount USB stick and metadata, which is this folder here. Now you can zip this up if you wanted to. You would add a Z into the options here and put a .gz on the end, but we don't really want to compress the files on this because it's already going to be running pretty slow on the Raspberry Pi 4. So we're just going to create a copy of the full sort of sized files into the zip file just for storage. So I'm going to press return here, and this will start adding those files into the tar file. It will take a few moments, and once it's done, we'll have a look at what it looks like. So whilst this is doing its tar in the background, we can see that the load is pretty high on the Raspberry Pi here, just using tar itself. So from this, we know that we don't want to do this too frequently because the Pi is going to get absolutely hammered when it does so. But it is important to do, so we do need to keep at least, maybe once a day or a couple of times a day, just to have that zip of the metadata, just to ensure we've got some good working backups of it. The reason you want to have more than 1 day's worth is because if for some reason you don't realize your metadata has gotten corrupted, you may go a day or two without realizing, and then if you try and get back to one of your zips from a couple of days ago, that may also contain corrupted information. So we're going to keep, say, a week's worth of zip files, and then we've got at least a good few days where I imagine most people will be checking their node every now and again. So you should hopefully spot if there are any problems, and then you can rescue one of your zip files and restore your metadata if required. We can also have a look in IOTop. Now to install IOTop, you can just do an apt-get IOTop and get that installed. I installed it just so I could see what was going on the disks here. Now this will be a bit slow because it's basically reading and writing to itself at the same time, so that will slow things down a bit. You could obviously back this up to another location. If your external drive that you've plugged in has got some space left that you haven't shared, then that would be another good place to send it to. But just for ease, I'm just doing it to the USB stick itself. Okay, so our tar has finished running, so let's just have a look and see what we have. So you can see here we've got the metadata backup, we've got today's time and date as well attached to it. So we know now that this tar command is correct. So we can now select that and add that to our notepad file for future reference. So next up we want to schedule exactly when our rsync is going to run. So the more frequent the better, obviously, because you wouldn't necessarily lose any contracts if your SD card died, but we don't want to do it too frequently because it does obviously put a bit of a load on the system. So I'm going to go into crontab -E, and we can edit the crontab here. So I've put the crontab command on the screen here so you know exactly what I'm doing for the setup of the command. So basically we're going to get this to run every 4 hours. So to do that we need to type in 0 space star /4 and then star star star, and that will configure this to run every day and every 4 hours. So now we're going to paste in our rsync command, and we want to send this to a log file just so we can monitor it just in case there are any issues. So I'm going to send this to /var/log /rsync.log. Okay, so every 4 hours our rsync will run, copy the metadata folder, and we're just going to get rid of this slash here, so it actually copies the whole folder here. So the whole of the folder is going into the USB stick, and it's going to the rsync log. So we can press escape, write and quit. Just copy this first because we're just going to test it again. So let's write and quit. I'm going to right click now and just test our command, just make sure it does sync and that it does create the log file. We're going to just tail the log file while it's doing it so we can see what's happening. So we can see it's copying the consensus DB, so that'll be the file that probably updates the most out of all the files in the metadata folder. And that is the biggest file as well, so this will probably take a fair while to run. Okay, so our rsync is finished, and if we just have a look in the folder, we'll see it hasn't created a new one, it's just updated the metadata folder here. So we know that the rsync command is working fine, and if we go to the log, we can just have a look. We do a less, paste that in there. We can see exactly what was copied over, the census, a few JSON files, a few other bits and pieces. So that's all very good, but we do also need to add another command into this so that if anything does get deleted from the metadata folder, it also gets deleted from the backup on the USB stick. So this is what I was saying was what looked like a bit of a scary thing, but it's not too bad. We're just going to go back into cron tab -E, going to go down to our line here, press I to insert, go across to here, and after this we're just going to put in -- delete, and then put a space afterwards. So basically anything that gets deleted by SC Prime in the metadata folder will also then be deleted on our destination as well. So we can now escape, write and quit. In fact, if we just do a cron tab -L, we can copy this, and we can do a dry run on this as well, just for fun. -dry -run. And we can see here exactly what would happen if when it next runs. It's basically going to delete these two fingerprint buckets, and these files here have updated already, so these will be updated as well next time it runs. So we know it's going to work properly. It's going to delete the files that have been removed already, and we'll know that our metadata folder on the USB stick matches exactly the metadata on the internal micro SD. Okay, so next up we want to define our schedule for the sort of zip backups or the tar backups here. So again, we're going to go to cron tab, and we're going to scroll down and we're going to set up our archive here. So we know that the zip file is going to be around 3 GB at its current size at least. So we want to make sure that we delete files that are older than X number of days, because we don't want our USB stick to fill up. So I'm going to get this to run, say, once a day on every day of the week. We're going to run a command that will find any files that are older than, let's say, 7 days, and it will remove them. So for this, we're going to write press insert, 0, 1, ****. So what we're going to do is use a program which is called find. So we're going to do find, and then in our location, which is /mount /USB stick, and then a space, and then where the modified time, which is mtime, is greater than 7 days. And we'll tell it to execute the command remove -f, which is a force, curly brackets, \. So what we also want to do is pop a slash here and do a star.tar, so it's only looking for tar files. We don't want it to affect the actual metadata folder itself. So anything in the USB stick with any file name with .tar on the end, which is greater than 7 days, we will remove it. So once you're happy, just do a escape and then :write and quit. And we can just do a quick find here manually just to see what it's going to find with that part of the command. And you can see it does find the tar file. Now obviously it's not going to find anything older than 7 days because we've only just created this today. So we will have to just double check that it does run as we wish. Okay, and we also want to put in our tar file here to schedule that to run once a day. So it's pretty much the same as the line below in terms of setup for the schedule. But the command we're going to put in here is slightly different to the one we ran on the command line. We're putting in the full directory path as well, and we do need to escape these % signs. You see it all goes yellow. So I've put these in the description as well. If you do want to copy and paste them, it might be a bit easier. But this is our current setup. So we've got the rsync every 4 hours, then once a day. We've got a metadata backup to a tar file, just as a sort of cold storage almost of the metadata file. So that will run every day. And then every day also we'll check to see if we've got any tars that are older than 7 days, and we'll remove them if we have. This is just so that our USB stick doesn't fill up. You will, however, obviously need to monitor the space yourself over time, because the metadata will probably increase in size as more and more contracts get added on, so it's best to keep an eye on this if you can. We can escape and write and quit. Okay, so next up we're going to go through resizing our shared storage, or what we're actually sharing on SC Prime, and then moving the metadata across onto that disk so that we can store it on the external USB disk rather than on the internal microSD or on our backup USB stick. So if you remember, we have got SC Prime, our 5 terabytes of data on here. So this is our mount point that we want to change the folder size of. And we've got our commandlets in here. So I'm going to just go into current version here. And this is where SPC is located. Okay, so if we want to resize our folder, we're going to have to use a command, which is basically SPC host folder resize. Then you pop in the directory or the location that you shared when you added the folder, and then you set the new value that you wish it to be. Now, because I've set mine to 5000 as a shared disk originally, it's not going to let me do this because it just can't possibly resize the data without moving some other bits of data elsewhere. So we're going to get an error message when I do this. Ignore this part here. This is just because I've got mine running on port 14280 rather than the default 4280. So if I hit return here, we'll see it's unable to migrate all sectors. So I had a look on the Discord, and yeah, it's confirmed that basically you can't make it any smaller than what you've set if you've set it to the maximum size of the disk. So if we did want to store our metadata in here, we would need to delete the contents of the shared folders, and we would lose any locked collateral. So let's have a look. Let's check what our wallet says first. And again, I just need to paste in this bit here. Right, so confirmed balance 301 SCP. So let's see what contracts we've actually got in use. Okay, so I'm going to do SPC host contracts. Again, forget the bit on the end unless you have changed your default port. And we can see here we've got some locked up collateral in use. Let me just do that again so we can see it a bit better. So we've got 4.69, 4.64, as you can see. Now this isn't full SCP, this is, I don't know what this stands for, whether it's micro or something, but it's not the full, it's not full SCP that we've got locked up here. So we are going to be okay to just delete this disk. This is just the test data that they put on when you set up your node. So we can see here, we've got the 3 contracts here, which have succeeded. So in theory, we're going to lose about, 13 or 14 USCP, which again, I'm not 100% sure what that value stands for, but we'll find out shortly. So I'm going to do a folder remove now. So we're going to do a /SPC host folder, and then we'll just do the help just to confirm. So remove a storage folder from the host. So I'm going to do that. So folder remove. We're going to put in the folder we're going to remove, which is mount/SC Prime, and this is the one that we are going to take off. So I'm going to click on that. It's going to come up with the error because I haven't put in my port number, which I shall just get. Okay, so let's do that. We should get a message. We're getting an error message here. So what we're going to do is a force to try and get it to force remove it, just with a -F rather. So force removing will completely destroy your renter's data and you'll lose your locked collateral. So I'm going to press yes on this. And the folder has been removed. So we can now check our wallet status and see how it looks. So SPC wallet. Stick in our bit here. And you can see we've still got 301 SEP. Okay, so our wallet still looks okay, and we've removed the folder now. So let's just check our mount point. So we're going to go into CD mount, SE prime, and it is now empty. So we're going to resize this, and we're going to leave some space on the drive itself just to make sure we don't have any issues in the future if it did fill up. So we're going to do an add folder now. So we're just going to go to, going to do a change on this, just do an add, mount SC prime, get rid of this, and we're going to say, we're going to go with 4850 actually, I think. So we're going to leave 150 gigs free here, so we have the option in the future to move our metadata across to this disk, and we also have 50 gigs free to allow the disk sort of breathing space when we're using it. So if you have more than 4 or 5 terabytes, they do advise that you actually create multiple folders at smaller sizes. So you might have an SEP Prime 1 or 2, 3, and then have, say, a 2 terabyte, another 2, and a 1 terabyte, or 900 gig maybe. But again, this is only a sort of simple single drive, so I'm just going to keep it like this. So we're going to add in the mount point here at 4850. Helps if I go into the right location. Okay, let's give that another go. Okay, so we've now added 4.85 terabytes onto our shared folder. So now I'm going to go into the mount point. So we're going to come out of here, go to SE Prime, have a look here, see what's there. We should see the files that have been created now. Okay, so we know we've got 150 gigs now to play with, so we can actually create the metadata folder into here. So let's give that a try. Okay, so we're going to use our rsync command to copy the metadata from our internal micro SD card on to the external hard drive now. So to do that, we're just going to do rsync -av /metadata, and that will copy that whole folder. And we're going to copy it onto mount /sc prime and just stick it in there. So that folder will just be copied across into the root on the external disk. So I'm just going to run that. Now I have stopped the SC Prime service, so to stop it, you have to go into your current directory. I'll just show you quickly. So we'll come out of here. So we go to our current version, and you just do an SPC stop. I have to stick in my localhost bit here, but you can see it's refusing to stop because I've already stopped it. So that's all good. So we will now go back out of here into our SC Prime folder, do our rsync, just check what's in here. Nothing yet. So rsync -av /metadata, get the whole thing into mount /sc prime. Kick that off. So we're just checking another window here, the progress. We can see the metadata folder has been created, so let's have a look inside. And we can see all the details, all the data is now inside that metadata folder. So as soon as this is copied, we are going to edit our startup script to make sure that it points at the new location. And after that, we can update our backup script and also point them to the new location of the metadata. So you can see it's pretty quick to finish. So we've now got all our metadata in here. So if we come out of here, we can do disk usage, DU. We'll have the human readable format on metadata. And we can see that's the 3.1 gig metadata that we were expecting. So now we're going to go and edit with Vi. I'll do it in the bigger window. Edit with Vi, our user local bin, SC prime startup or SCP startup file. And you want to edit, obviously, the location or the directory -d to point to your new location. So I've updated mine here to mount SC prime metadata. I've also updated the SPD data variable up here. Now we can quit out of here, write and quit, and we can run the startup command now. So we need to go into our current version again. So we'll come out of here with cd ... go into SC prime current version. In fact, I don't know why we're doing that. We're going to run the startup script. So let's go to user local bin and we'll run the startup script now and just see if everything starts up okay. Put a dot / in front of it. And again, we can use our other window to just check the progress of things. We can see SPD is running in the background there. We can check the status of the consensus as well whilst this is running. So if we go to our current version, we can do a .spc consensus. And I do need to include my little bit extra here, I'm afraid. So we can see we're synced and it's all looking okay. We've got the finished full startup in 50 seconds. So it took a bit longer to start up, but it has at least finished now. Still doing some bits and pieces. But now we can actually go and edit our cron tab. So let's do that on cron tab -E, because we're going to edit where we're backing up our metadata. So remember we did it from the root of the SD card. We're now going to do it from our external 5 TB drive. So it's going to be /mount, press insert or I to insert. So it's going to be /mount /sc prime /metadata. So that's all we need to do to add that in. And that is still going to back up to our external USB stick. So just double check everything looks okay. And we've still got our tar files being created as well. So that's all we need to change in there. So we can press escape, write and quit. And we should be back up and running. Okay, so we can see if we type SPC host, we can see all the details of our host here. So the storage we're now sharing, the price, the duration, accepting contracts, and our storage folder. So we've got our storage folder and it's all set up now and you should be good to go. So we've now got backups, we've got backups of the backup, and we've moved the metadata onto a quicker drive to make things a bit faster and a bit more reliable, hopefully. So that should ease off some of the pressure on the internal micro SD card. And if we do have any problems with our metadata, it's all backed up onto an external USB disk. So we can just simply copy that metadata back across and restore it and potentially only lose, a few hours worth of contract data. So a lot of people have asked what the potential earnings are of having an SC Prime miner. And the best way I can answer that is really to just work it out. So you can go on to the SC Prime Grafana site here, and you can basically see a list of all the current providers and what their storage size is, how much is in use, what they're charging. So it's as simple really as just going into one of these and working out for yourself. So if we have a look at this one here, for example, this one's been online for quite a while, I imagine, and we can see they've got a 5 TB drive. They've only got 1.3 TB in use. They've got 3.61 remaining. They're compliant, and you can see exactly what they've managed to get so far. So last month, that's November, they got 20.2 SCP for compliance, 17.6 for their free capacity, and 221 for their used capacity. So that sounds like quite a lot actually. Let's work out exactly how much that is. So we've got 20.2 plus 17.6 plus 221. So that's 258 SCP they got for their node. So if we times that by the current value, which is $1.18, they managed to get $305 for their node in November. Now this month, they're going to get pretty much exactly the same. They've got a tiny bit less for the compliance, but that should round up to 20 before the end of the day. So they're getting a nice little $305 per month for their node. So we're looking at another provider here. So they've also got 5 TB with 2.37 used, and that's a bit more than the previous one. And they're actually getting a lot more for their used capacity here. So we can work this one out as well for this month for them. So they've got 19.8 plus 21.9 plus 275. We can times that by 1.18. So this one here is earning $373 a month so far. Now, bigger isn't always better. So if we look at the very top person on the list, for example, have a look. So this person here has got a total of 592 terabytes. and they've only got 817 gigabytes in use. So they've paid an absolute fortune for their storage, but they're currently only getting, let's have a look here, 19.1 plus 3.82 plus 47.7. So currently this month they've only earned times 1.18, $83. Now if you compare that to the 200 or 300 that the 5 terabyte users that we looked at got, you can see that it doesn't matter how much storage you've got, it really depends on how much is actually being used. So obviously in the long run, if this provider stays online and this does keep filling up and filling up, then they'll have more potential in the future. But it doesn't mean to say that if you stuck a 50 terabyte system on the network that yours would fill up first and you'd get more money, because the data is spread out across the providers to provide redundancy. So it doesn't all just, let's fill up here and then move on to the next one, fill up here. It doesn't work like that. It's all spread out, I presume, equally across the whole network. So I hope you found this video useful. If you did, please do click the like button and be sure to subscribe to my channel. If you've got any questions at all regarding this setup, then do leave them down below in the comment section and I'll do my best to answer them if I can. Always be sure to check the pinned comment in case I provide any updates to this video. It could be that I've made a mistake in the video which I need to correct, so just check that out as well. Be sure to check out my other videos on SE Prime and other passive income methods. And again, thanks for watching, and I'll see you in the next video.